So this one is exercise 2 related to matter and the gas laws. The first question, explain in terms of molecules why it is possible to compress a gas but not a liquid. So we can compress a gas but we cannot compress a liquid. So what is the main reason for that? Because in a gas the molecules are far apart, like they have more space between them. Where in liquid the molecules are close to each other. So in liquids, the molecules are close to each other. That's why liquids are difficult to compress. So answer here, in terms of molecule, why it is possible to compress a gas? The reason is that because in gas, the molecules are far apart, where in liquid, the molecules are close to each other. That's why we cannot compress a liquid easily. The second part, we have two containers which are made of insulating material. They have the same volume of the water at room temperature. The container do not have a lid, like there is no cap or a lid is there on the container. The volume of a liquid in each container gradually decrease or change. After a certain time, the temperature of the water has decreased below the room temperature. Like if we started this, the water or the liquid start to evaporate, maybe the liquid temperature was 30. But after some time, the temperature of the liquid, the level of the liquid decrease and the temperature of the liquid also decrease. So explain in terms of molecule why the temperature has decreased. So what is the reason why the temperature decreases? So mainly what happens, the most energetic molecules which are there at the surface of a liquid will escape. So the molecules, because there are molecules at the surface and there are molecules under the surface, but the most energetic molecules which gain energy from the surrounding, they escape, and the molecules which are left behind, they will have a low energy. That's why the liquid temperature will decrease. So answer here, the most energetic molecules at the surface will escape, and the molecules which are left behind have low energy. That's why it is a cooling process, or it cool down the liquid. One of the container is a wide and shallow. So we have two containers. One is wide and shallow, another one is narrow and deep. So which container will have a, the question is predict which container has the greatest rate of cooling or rate of evaporation. Wide and shallow or narrow and deep? Which one? On the left hand side, it is wide and shallow, the container. And on the right hand side, we have narrow, the surface area is small, and it is deep. So which container the evaporation will occur at a faster rate? Yeah, that's right. The wide and shallow will have a faster rate of evaporation. So one mark is for mentioning wide and shallow, and the second mark is for explaining the answer, because in a wide and shallow, greater number of the molecules exposed to the surrounding. That's why the rate of evaporation is much faster or higher. Is it clear? In question 2, what happens if the temperature of the gas increases or increase? So what will happen when we increase the temperature of the gas? So we can say the gas molecule will move faster, or we can say the kinetic energy of the particle will increase, or they will hit the wall harder, or they will collide often with the wall of the container. So in short, I can say they will move faster, or the kinetic energy will increase. A quantity of a gas is contained in a sealed container. Sealed container means a container which is not allowing any gas to escape, and it is having a fixed volume. Fixed volume means like the volume of the container can be changed. The temperature of the gas increase. So we have the gas molecules inside and we are supplying heat energy, so the temperature is increased. State in terms of molecule two reasons why the pressure of the gas increase. So why as we are increasing a temperature, why the pressure of the gas is increasing? What are the two reasons for that? Number one, that these molecules will collide often. That is one thing. Number two, and they will hit the wall harder, or there will be a greater change in momentum. So it will increase the number of the collision. The gas molecules collide often with the wall of the container. And the second thing, it will also increase the force exerted on the container or walls of the container. So these are the two reasons why, as we increase the temperature for a fixed volume of a gas, the pressure will also increase. In part C, a helium-filled weather balloon is there, which is held at the ground. The volume of the balloon is 4,800 meter cube. So that is the initial volume. And the pressure of the helium is 98 kilopascal or 98,000 pascal. That is a initial pressure. The balloon rises and release and rises to a height where the volume of the balloon is 7,200. So that is the second volume. The question is calculate the new pressure. So how we can work out the new pressure? We'll use the formula P1 V1 equals P2 V2. So first pressure multiplied with first volume equals to second pressure multiplied with second volume. The first pressure when the balloon was held or it was there on the ground, the first pressure was 98 kilopascal. So you can, if you convert kilopascal into pascal, the final answer of pressure will be in pascal. Or if you are not converting it, then if you just write 98, so the final answer of the second pressure will be in kilopascal. So if I'm writing 98 and the first volume is 4,800, the second pressure we don't know, and second volume is 7,200. The 7,200 is multiplied, other side it will be divided. So 98 multiplied by 4,800 divided by 7,200. So when we multiply all 98 into 4,800 divided by 7,200, this will give us the new pressure, which is about 65,000 pascal or 65 kilopascal. So the new pressure after solving, it will be 65, the answer. And because the initial pressure, the first pressure was in kilopascal, the final pressure is also in kilopascal. So here the answer is 65 kilopascal. Or you can also solve this question if by converting a kilopascal into pascal. So if you're converting it, then it will be 98,000 pascal will be there. So if you're writing in pascal, the final answer should be in pascal. If you're using kilopascal, the final answer is in kilopascal. Suggest why it may be necessary to release helium from the balloon as it rises even higher. So why we have to release some helium from the balloon as the balloon is rising higher? As we know, the atmospheric pressure changes. For example, say this is the ground and we are releasing a balloon from the ground. We know at the ground level, the atmospheric pressure is higher. And this balloon is filled with a helium gas is inside. But when this balloon is released, it will rise as the helium is having low density compared to air. So it will rise. But as a result, what happens as this helium balloon is rising, the atmospheric pressure is not same. The atmospheric pressure is changing. It is decreasing because there at a higher altitude, there are few air particles. As a result, when outside the pressure is less or small and inside, the pressure might be higher. So what might happen? This balloon might burst. So reason why we should remove some of the helium from the balloon, so it will prevent the balloon from bursting, or it will reduce the pressure from inside the balloon, because otherwise if pressure from inside of the balloon is higher than outside, then this balloon will burst. Is it clear, this part? That why we should release some helium from the balloon, otherwise it will burst, as the inside pressure will be higher than the outside pressure, or pressure of the helium gas might be higher than the atmospheric pressure. In question 3, the hot plates are switched on and the temperature of the water in the pan start to increase. When the temperature of the water is below 100, some of the water evaporates. At 100, the water start to boil and its temperature remain constant. Pan A is having a small area as compared to pan B. So we have two pans which are having a different area. Pan A is having a smaller area compared to pan B, and they are filled with the equal amount of water. State and explain which pan has the greatest rate of evaporation when both pans of water are at the same temperature. Which one evaporation will occur faster, A or B? In which pan the evaporation will occur at a faster rate? Yeah, that's right. B, evaporation will occur at a faster rate. And what is the reason for that? Reason is because it is having a large area or large surface area. So the reason is large surface area, more molecules or particles are exposed to the surrounding. That's why it will have a higher rate of evaporation. Apart from a temperature at which it occurs, state how boiling differ from evaporation. Like, what is the difference between boiling and evaporation? Any one difference you have to mention? There are many differences.
Yes, evaporation occur at any temperature. Boiling has specific.
Good. So evaporation can occur at any temperature, but the boiling occurs specifically at a specific temperature. Or in evaporation, there are no bubbles. Boiling, the bubbles will form. Evaporation occur only at the surface, where boiling occurs throughout the liquid. So you can mention any one of them. When the water is boiling, the thermal energy being supplied to water at a rate of 920 watt. What is the meaning of 920 watts? 920 watts means like we are supplying 920 joules every second to boil the water. Explain the effect on molecule of the thermal energy being supplied. Look, when we are changing the state, the molecule, there are intermolecular forces or force of attraction between the molecules. So when we are changing the state, this force of attraction or intermolecular force break down. Like there are intermolecular forces or force of attraction between the molecule. So when we are supplying 920 joules every second, so what happened to this energy supplied? The energy which we are supplying is used to break the intermolecular forces, like forces between the molecules. So why it's of 2 mark, 1 mark, but you will mention like energy is used to break the intermolecular force so the molecules or the particles can move away from each other. And remember one thing, that whenever there is a change in state, there is no change in temperature. Like if the water start to boil at 100, it will convert from liquid to gas and the temperature still remain 100. Why? The temperature does not change even though we are supplying heat, because the heat energy or energy is used to break the bonds. So the 2 marks here, the energy is used to break the bonds, and move the molecules away from each other. So we use that energy to break the intermolecular force and move the molecules away from each other. In question 4, a test tube containing a solid wax is heated by placing it in a beaker of a hot water for several minutes. The solid wax becomes liquid. Explain in terms of molecule how solid differ from liquid. So here, in terms of molecule, you have to tell the difference between solid and liquid. So what is the difference between solid and liquid in terms of molecules?
In solid, the molecules are closely packed.
Right. Closely packed
And
or regular arranged. That's right.
in liquid, they are randomly moving
Yes.
and are not in a lattice.
Good. And another thing, like molecules have a regular arrangement, as you mentioned, and molecules can only vibrate in solid, but in liquid, the molecules can move around each other. And in solid, they are tightly packed. In liquid, they can move past each other. Then the same answer, explain in terms of molecule why thermal energy must be supplied for a solid to become liquid. So what we have to do, the same idea, because energy is used to break the bonds and move the molecule away from each other. So whenever we want to change the state, and remember one thing, when solid turn into liquid or liquid turn to gas, there is no change in temperature. The test tube is removed from a hot water, is then held in a clamp stand. So first what we did, we melt the wax, we convert into liquid. And now we cool down the wax. So here we have a liquid. When the temperature is not changing, it means the state is changing. So it means the liquid is turning into solid, this point, and then we will have solid. In the question, we have to identify or mark using the melting point. So how we work out the melting point? Melting point is the temperature at which a solid turn to liquid, or it is vice versa, like a liquid turn into solid. That is also a freezing point or a melting point, same thing. So here a liquid turn into solid at what temperature? We'll draw a line. You have to show this on the graph. You have to draw this line and identify. Here each box is representing, because from 20 to 40 there are 10 boxes. So 10 boxes equals to 20. So each box equal to 2. So this is 42, 4, 6, 8, 50, 52, 54, 56, and 58. So it is between 56 and 58. So it is about 57. So 57 is the melting point or a freezing point of this wax. In question 5, in an industrial process, a gas that is already at a high pressure is trapped in a large cylinder. This is a graph which shows a relation between a pressure and the volume. As we know, when two quantities are inversely proportional, there will be a curve. Describe a relation shown by the graph between a pressure of the gas and the volume it occupies, and explain relation in terms of molecule. So first, what is the relation? As you can see, that if we are decreasing a pressure, volume is increasing, or if we are increasing a pressure, the volume is decreasing. So there's a curve. So it means when the pressure increase, the volume of the gas will decrease. And in terms of particle, we have to explain. So when high pressure is applied, the particles come closer to each other. Which reduce the volume. So that's the relation between pressure and volume, which is also known as the Boyle's law. Determine the volume occupied by a gas when it is released into atmosphere where the pressure is 0.1 megapascal. You will need to use the data. Look, in this question, we want to find the volume when the pressure is 0.1 megapascal. But from this graph, it is difficult to find the pressure of 0.1 megapascal because 5 boxes equals to 10 boxes equals to 5, so each box is 0.5. So 0.1 is a difficult, we cannot draw a line from 0.1. Then what we can use a relation here that any pressure, like the first pressure and first volume is equals to second pressure and second volume, like P1 V1 equal P2 V2. Now what about P1 and V1? So we can take any pressure and volume. Example, I'm taking this point, but I can take any of the point. It does not make difference to the final answer. So if I take this point, that pressure is P1 and the volume at this pressure is called V1. So I say P1 is equals to 10 megapascal and V1, the volume, 10 boxes are equal to 0.1. So each box is equals to 0.01. So V1 is 0.02. So the first pressure we took 10 and the volume at that pressure is 0.02 because 10 boxes equal to 0.1. So each box is 0.01. So 2 boxes will be 0.02. So P1 V1 equal to P2. At what pressure we want to find the new volume? We want to find a pressure at 0.1 megapascal. We want to find the volume. So if the pressure is 0.1 megapascal, what is the volume? The volume will be V2. So when we simplify 10 into 0.02 divided by 0.1, this will give us the volume of the gas, or the volume this gas will occupy at 0.1 megapascal. So when we simplify this, it will come out as the volume, the unit of the volume here, that is in cm cube, I think, meter cube. Okay. So when we simplify this, 10 into 0.2, it will be 10 into 0.02, it will be 0.2, and 0.2 divided by 0.1, so it will be 2 meter cube. So the new volume of the gas will be equal to 2 meter cube. Is it clear, this question? That how we work out the new volume? As we know, we can take any value, we'll get the same answer. It does not make difference. So you can take any point. You can take the first point, this point as P1, and the relative volume will be P1. Is it clear, this question? Okay. In part B, an unused cylinder of the compressed gas is moved into a cold warehouse. So the temperature is decreased. State how the decrease in temperature affect the motion of the molecules. So how it affect the motion of the molecule? As temperature decrease, the molecule will move slower. And what happened to the pressure? The pressure will also decrease, because we know, so motion of the molecule, the speed of the molecule will decrease and the pressure will also decrease as the molecules exert less force or smaller force on the walls. In question 6, some gas trapped in a metal cylinder by a piston. The position of a piston is fixed. Like we have a container and this piston is there. The movable lid is called a piston. But here in this question, the piston is fixed. The cylinder is moved from a cold room to a warm. Explain in terms of molecule what happened to pressure. So in this case, like the previous example, we were decreasing a temperature, but this example, we are increasing a temperature. So if we increase the temperature and the volume is fixed, the pressure will also increase. And what is the reason for that? The molecule will move faster. So pressure will increase, or Why the pressure increase? Because the molecules move faster or they will hit the wall often. The piston is now released and it moves to a right and finally stop. So basically the cylinder is placed in this manner. Like initially this was a position. Then what happened? We allow the gas to expand. We move the piston more towards the right hand side. So the same number of the molecules, but they have more space. So if the volume increase, what happened to the pressure? The pressure will decrease. So the piston is now released and it moves to the right and finally stop. So as this piston moves towards right and finally stop, what happened? The pressure will decrease. And the reason for that, because the volume is increasing and there will be less collision between the molecules and the wall of container. Or molecules, the number of the collision or the frequency of the collision will decrease. So as we increase the volume, will decrease the pressure, and the reason is that because there are less collisions or few collisions between the molecules as well as with the wall of container. In question 7, a balloon contains a fixed mass of a gas. Explain in terms of momentum how the gas in the balloon exert a pressure. So in terms of momentum, this is a very important question that you will find repetition is there in this type of question that explain the pressure exerted by the gas in terms of momentum. So pressure exerted by the gas in terms of momentum, that gas molecules are moving randomly. So when they collide, it changes the momentum, and due to change in momentum, it exerts force. The same question is there. Sometimes it is of 4 marks, sometimes 3 marks, sometimes 2 marks. But the answer remains the same, that the gas molecules are moving randomly. That is one thing. Then as a result, when the gas molecules are moving randomly, they will collide with a wall. And changes the momentum as they bounce back. And due to the change in momentum, as we know, whenever there is a change in momentum, there is always a force. So due to change in momentum, it will exert force on unit area, which create a pressure. In part B, explain in terms of molecules why the pressure of the gas increases when the volume of the balloon decreases and the temperature is kept constant. So when we are decreasing a volume, the particles will come closer to each other. The number of the collision increases. That's why, or there will be more frequent collision with the walls. That's why the pressure will also increase. The initial volume of the gas is 500 centimeter cube. The pressure is 1.1 exponent 5 Pascal. The volume is reduced to 200. We want to calculate the new pressure. So we have the formula P1 V1 equals P2 V2. So first volume, this is first volume, first pressure, second volume, and we need the second pressure. The first pressure is 1.1 exponent 5 Pascal, which is atmospheric pressure. First pressure is 1.1 exponent 5 Pascal, which is atmospheric pressure. First volume is 500. The second pressure we don't know, and the second volume is 200. 200 is multiplied here, other side it will be divided. It will be 1.1 exponent 5 into 500 divided by 200. This will give us the second pressure, which is about 2.2, and we know the volume decrease, so the pressure should increase. So 2.2 into 10 to the power 5 Pascal. That is the new pressure which is exerted by the gas which is present inside this cylinder. So these are some questions related to topic I have solved 7 of them, and there are about 20 questions. Remaining you will solve. I'll share this exercise with you.